If you've used a public restroom stall with a gap under the door, you've experienced this exact moment. You walk in, and there, staring back at you, is a gap. Under the door, above the floor, sometimes a full 12 inches high, wide enough that you can see the shoes of the stranger in the stall next to you, and they can see yours. In a place that's supposed to offer one of the most private moments of your day, you're given almost no privacy at all. So why does this exist? Why does the one room specifically designed for privacy have a built-in window at ankle height? Today we're breaking down the surprisingly deliberate and surprisingly regional reasoning behind one of the most universally awkward pieces of design most people have simply learned to live with. Before we get into why this gap exists, there's something important to clear up first. This isn't how bathroom stalls work everywhere in the world. If you've traveled to certain other regions, you may have noticed something strange happening in the opposite direction: complete floor-to-ceiling stall doors with no visible gap at all, sometimes even a fully enclosed private room for each toilet. Many travelers report a genuine moment of culture shock the first time they use a public restroom somewhere with fully enclosed stalls and realize they can't see a single sliver of the person next door. For people who've only ever used low-gap stalls, complete privacy in a public restroom can feel almost unfamiliar. This tells us something important right away. The low-gap design isn't some universal engineering requirement. It's a specific choice, made for specific reasons, that became deeply standardized in certain regions and largely stayed that way. To understand why, we have to go back to the early 20th century, when large-scale commercial and office buildings began needing standardized restroom facilities for hundreds, sometimes thousands, of employees at once. One particularly influential building in this story is a massive office headquarters completed in 1906, designed by a well-known architect of the era. He wasn't just designing offices, he was designing an entire integrated workplace system, including how the building's restrooms would function for a huge workforce. His restroom partitions used shorter doors that didn't reach the floor, a practical, efficiency-driven design choice for a building meant to house enormous numbers of workers moving through communal facilities quickly and hygienically. Many of his architectural decisions in this building became influential far beyond it, and this partition style is often pointed to as one of the early templates that later commercial restroom manufacturers followed at scale. Once we get past the historical origin point, it's worth being honest about the biggest driving reason this design stuck around and became standardized across the commercial restroom manufacturing industry. Shorter partition doors and panels use significantly less material than full floor-to-ceiling versions. When a manufacturer is producing thousands of identical stall partitions for stadiums, airports, schools, office buildings, and shopping malls, even a modest reduction in material per unit adds up into enormous savings at scale. On top of that, shorter partitions can be manufactured to standardized, universal sizes, since they don't need to be custom measured to match the exact floor-to-ceiling height of every single building they're installed in. A floor-to-ceiling door, by contrast, needs to be precisely fitted to each specific location's exact dimensions, which adds cost, complexity, and installation time. Standardization is cheaper, faster, and easier to mass-produce, and commercial buildings have overwhelmingly prioritized exactly those three things for over a century. Here's a detail almost nobody thinks about, but it's genuinely one of the most important engineering reasons behind the gap. The floor underneath most commercial restroom stalls isn't actually flat. Public restroom floors are typically built with a deliberate slope, angling gently downward toward one or more floor drains. This is done so that if water spills, if the floor gets mopped, or if a plumbing issue causes any flooding, the water naturally flows toward the drain instead of pooling. This sounds like a small detail, but it creates a real structural problem for door design. If a stall door were built to reach perfectly flush with the floor, it would only fit correctly at the single point on the slope where it was initially measured. Anywhere else along that slope, the door would either drag against the floor, making it difficult to open and close, or leave an inconsistent, uneven gap that looks even worse than an intentional one. By deliberately building in a modest gap from the very beginning, manufacturers sidestep this entire sloped floor problem. The same door design works consistently across every stall in the building, regardless of exactly where it sits on that slope. There's another major factor that isn't just about cost or convenience, it's about legal accessibility requirements. In many places, disability access laws set specific requirements for accessible restroom stalls, particularly larger stalls designed to accommodate wheelchairs. These regulations specify minimum clearance requirements at the base of stall doors, partly to ensure there's enough functional space for a wheelchair user to maneuver, and partly to allow emergency responders or facility staff enough visual and physical access to assist someone in a mobility device if something goes wrong inside the stall. Once accessibility codes established minimum gap requirements for these specific accessible stalls, it became far simpler and far cheaper for manufacturers to apply one consistent partition design across every single stall in a restroom, accessible or not, rather than producing two entirely different door systems side by side. Consistency across a batch of manufactured products is almost always cheaper than producing multiple specialized variants. Here's where the design starts to feel less like an oversight and more like a genuinely deliberate choice. That uncomfortable gap serves a real documented safety function. It allows other people and building staff to visually confirm whether someone inside a stall is in medical distress. Public restrooms are, statistically, a location where medical emergencies do occur, from fainting to seizures to more serious cardiac events. If a bathroom stall door went completely floor to ceiling with no visibility whatsoever, someone experiencing a medical emergency inside could go unnoticed for a dangerously long time, since from the outside, a fully sealed door gives no visual indication that anything is wrong. A visible gap allows a passerby, a coworker, or a family member to glance down, notice an unusual position, an unmoving figure, or a person who has fallen, and get help immediately rather than after a prolonged, unexplained delay. This same visibility gap is also cited by parents and caregivers as useful for a different reason entirely. Being able to quickly check on a young child using a stall independently, without needing to fully open the door and eliminate their sense of privacy altogether. There's a less comfortable but very real reason cited consistently by architects, building managers, and facility designers. Reduced privacy inside a stall makes certain undesirable activities like drug use or other illicit behavior meaningfully less practical to conduct undetected. Complete privacy, ironically, makes public restrooms a more attractive location for exactly the kind of behavior that facility operators are trying to prevent. This isn't about assuming the worst of every restroom visitor. Most people using a stall gap are obviously just using the toilet normally. But from a facilities management and public safety perspective, a small amount of visible space acts as a passive deterrent, discouraging activities that require true, complete privacy to go unnoticed, without requiring any active security monitoring or staff presence inside the restroom itself. On top of safety, there's a very practical, unglamorous reason that matters enormously to the people who actually maintain these spaces: cleaning efficiency. Public restrooms need to be cleaned frequently, often multiple times per day in high-traffic locations like airports, stadiums, and shopping centers. A gap at the base of each stall door allows custodial staff to mop, spray, or even hose down the entire restroom floor in a single continuous motion, without needing to manually open, prop, and individually clean around the base of every single stall door one at a time. This might sound minor, but across an entire facility, cleaned multiple times daily, every single day of the year, this efficiency adds up into a genuinely significant reduction in labor time and cost. A fully enclosed stall, by contrast, traps moisture, debris, and grime specifically at floor level, right along the base of the door, precisely the area most prone to bacterial growth and mold if it isn't easy to access and clean thoroughly. There's one more reason that's rarely discussed directly, but is genuinely important: ventilation. A fully sealed, floor-to-ceiling stall traps air, and specifically, it traps odor, inside a small enclosed space with limited airflow. The gap at the bottom, along with smaller gaps often present along the sides of the door, allow at least some passive air circulation in and out of an individual stall, helping prevent the kind of trapped, concentrated odor that would otherwise build up in a small sealed compartment used by dozens or hundreds of different people throughout a single day. This raises an obvious question. If there are this many legitimate, practical reasons for the gap, why do so many other regions manage to build fully private, floor-to-ceiling restroom stalls without running into the same problems? The honest answer is that many of these problems simply get solved differently elsewhere. Some places use individual, fully enclosed single-occupancy restroom rooms instead of a row of stalls sharing one larger space, sidestepping the shared airflow and shared floor slope issues entirely. Others use active mechanical ventilation systems, powerful exhaust fans strong enough to handle odor control without needing passive gaps for airflow. Building codes, accessibility regulations, and cultural expectations around privacy all vary significantly from place to place, and in regions where complete privacy is treated as a stronger cultural priority, architects and manufacturers have simply been willing to engineer around the practical challenges instead of building the gap in as a shortcut from the start. In other words, the low gap approach isn't the only valid engineering solution, it's the specific solution that emerged from a specific combination of manufacturing costs, accessibility law, safety norms, and cultural comfort levels with public privacy that developed in certain regions over the past century. If this is starting to feel familiar, That's because it's the same underlying pattern we keep uncovering in this series. A design choice gets made for a combination of practical, economic, and regulatory reasons at a specific point in time. It becomes standardized across an entire manufacturing industry because standardization is cheaper and easier to scale than custom solutions. Once countless buildings are constructed around that standard, replacing it everywhere becomes expensive and logistically complicated, so it persists for decades, largely unquestioned, even as the original balance of reasons behind it shifts or becomes less relevant over time. Nobody sat down decades ago and said, let's make public bathrooms as uncomfortable as possible. Each individual factor, cost efficiency, sloped floors, accessibility law, medical safety, cleaning logistics, and ventilation, is a genuinely reasonable engineering consideration on its own. The gap is simply what happens when all of those separate, reasonable considerations get layered on top of each other and calcified into a default commercial building standard in certain parts of the world. So the next time you find yourself locking eyes with a stranger's shoes through a gap in a bathroom stall, know that you're not looking at a design flaw, or an oversight, or someone forgetting to finish building the door properly. You're looking at the overlapping result of manufacturing costs, sloped floor drainage, disability access law, medical emergency protocols, custodial efficiency, and basic airflow science, all stacked on top of each other, quietly shaping one of the most universally awkward moments of your day. Every uncomfortable, unquestioned piece of design around you has a hidden history like this one. We break down another one every episode, so if this kind of thing fascinates you as much as it fascinates us, stick around.